Hi everybody, today we're going to talk about lesson 66, prime factorization. This is part 1, division of primes. This will only cover example 1. You will need to watch part 2, a separate video, in order to look at example 2. So let's take a look. Before we talk about what divisions of prime is, let's do a quick review. So when we're talking about division of primes, we need to know about factors. Remember that a factor is any number that can go into a larger number evenly, or a larger number can be divided by equally. Okay, we've talked about factorization. So here I have the factors of 12. 1 times 12, 2 times 6, 3 times 4. So 1, 2, 3, 4, 6, and 12 are all factors of 12. They can all go into 12 evenly without any remainders. Okay? In lesson 65, we talked about prime and composite numbers. A prime number has only 2 factors, number 1 and itself, whatever it is. A prime number will always be odd, but not every odd number is prime, so be careful about that. A composite number has 3 or more factors. And remember, 1 is not prime or composite. It is just itself. So let's talk about what division of primes is, but first let's talk about prime factorization. What prime factorization means is that when we write a composite number, a number with more than 2 factors, as a product of its prime factors, we have written the prime factorization. So what does that mean? So let's take 12. If I have 12 and I multiply its prime factors, I would have 2 times 3 times 2. And I'll show you how we get that in a minute. So if I multiply 2 times 3, I get 6. If I multiply 6 times 2, I get 12, and I'm back to my original number. So this, then, 2 times 3 times 2, is the prime factorization. I would actually write it as 2 times 2 times 3. That's actually the proper way to write it. Or 2 squared times 3. Because 2 times 2 is the same as 2 squared. But now let's back up and figure out, how do we find these numbers? Okay, so this is what I'm looking for right here. So now let's back up and figure out how we get that. Okay, it's the first way. This method in this video is through division of primes. Okay, so we're actually going to do some division, but we're going to start down here at the bottom of our screen because we're going to be working up. You're like, okay, well that's kind of weird. But that's what we're going to do. So you need to skip a few lines on your problem and in your paper and write 12 as your dividend and a division sign. So step 1 is to divide by the smallest prime number that would go into 12. Well, we know 2 is a prime number, and since this is even, I'm going to divide by 2. So 12 divided by 2 equals 6. Okay, great. Now we ask ourselves, is 6 prime? No, it is not. So I'm going to divide again. And I'm going to divide 6 by its smallest prime number. Since 6 is even, I know 2 is its smallest prime. So 6 divided by 2 equals 3. Now, I'm going to keep going. Even though 3 is prime, I'm going to keep going until my quotient, or my answer, is 1. So I'm going to divide 3 again by its smallest prime. Well, it's not even, so 2 isn't its smallest prime. 3 is its smallest prime. So 3 divided by 3 equals 1. Now that my quotient is 1, I can stop. So here, if I look at my divisors, I have 2 and 2 and 3. These were the numbers we were looking for. If I was to take these three numbers and multiply them together, I would equal my original dividend of 12. So then I write my answer as 12 equals 2 times 2 times 3. Box it, and here's my answer. All right, we're going to do a couple of more examples because one just isn't enough. I know we don't have more examples in the book, so you're just going to have to work with me. Okay, so let's clear this one out. And let's do, this time, prime factorization of 18. So I'm going to start with my 18 down here at the bottom. And over here, I'm just going to write a quick list of the first few primes. 2, 3, 5, 7, 11. Okay, that's going to get me enough. Usually 2, 3, 5, and 7 are as far as I need to go. So step 1, divide by the smallest prime. 18 is even, so I know 2 will go into 18. So I'm going to divide by 2. 18 divided by 2 is 9. Now I'm going to divide 9 by its smallest prime. Its smallest prime is not 2 because it's not even, it's 3. So divide by 3. 9 divided by 3 is 3. I'm going to keep going until I have 1 as my quotient. So 3 divided by its smallest prime, which is itself, 3. 3 divided by 3 is 1. And so here I have 3, 3, and 2. So 18 equals 2 times 3 times 3. And I can check my work. If I multiply this together, 2 times 3 is 6. 6 times 3 is 18. So here I've just checked my work, and it equals what I'm looking for. Okay, let's do one more division by primes just to really make sure that you've got it in your head. Okay, so let's take this time, let's take the number 24. Okay, and again, I'm going to write my first few primes, 2, 3, 5, and 7, just as a quick reference list. And I divide by my smallest prime. It's even, so I'm going to start with 2. 24 divided by 2 is 12. Divide that by its smallest prime, which is 2. It's even again. 12 divided by 2 is 6. Divide 6 by its smallest prime, which is 2 again. 6 divided by 2 is 3. Divide 3 by its smallest prime, which is itself, 3, which leaves me a quotient with 1, which tells me I'm done. So here I have 4 divisors this time. So 24 equals 2 times 2 times 2 times 3. Okay, so this is all for division by primes. Please watch the other video, 66 part 2, to learn a different way to find the prime factorization, but this will help you on your written practice, part B. Okay? See you in the morning.